So I've sketched out this graph. Now, okay, let's see. This is 1, about right here. Alright, this is what we're looking at. We were moving in the x direction, and I'm going to plot an arrow. This is kind of like a vector here. 2 centimeters per second. But in the y direction, we are moving twice that. So I'm going to make this vector here about twice as long, or try to make it twice as long. 4 centimeters per second. Okay, and of course here, right at this point here, we're still moving in the x direction, 2 centimeters per second, but in the y direction we're moving 0 centimeters per second. Okay, because we're not going upward, we're not moving right north. But then as I move along this curve, as you can see what's going to happen here, as I continue to move 2 centimeters per second in the x direction, stays constant, what's going to happen to this number? Well, this number here is going to increase, right? This number is going to increase. Okay, so a little bit of an application problem. I guess we can go back and look at the graph again real quick. Alright, so I'm going to stay my cursor moving in this direction, constant at 2 centimeters per second. And what's actually happening in the y direction, this thing is actually speeding up. It's moving fast, isn't it? Okay, enough of that. Let's get busy with another problem. Alright, so this is going to be a little different. Of course, I'm going to attempt to draw something over here. This is the origin of the graph, and this is just some point on the graph. I'll pick another point. I'm going to draw a straight line and draw another, attempt to draw another straight line there. Okay. This is what we're working with. We're working with, once again, I think just like in the last problem, y is equal to x squared plus 1. And we're given dx over dt is equal to 2 centimeters per second again. So 2 centimeters per second. Okay, in this particular one here, we want to find the rate of change. So we want to find the rate of change, right? So when you hear rate of change, that we're talking about related rate problems. That's kind of like a key word there, rate of change. We want to find the rate of change of the distance between the origin and a moving point on the graph. So between the origin here and some moving point, we're wanting to find what is the rate of change of this distance, as you can see here. Okay, the rate of change of the distance between the origin and some moving point. There's a point moving along the graph here. So this is the path, and we want to find the rate of change of this distance. However, we're only given dx over dt. So what we're going to be finding is the rate of change. We're going to be finding dy over dt. And it's going to be just in a general sense. In other words, we're just going to have some x's over here. Okay, we're going to take the derivative of this, and we want to find dy over dt between this and the origin, right? So we need to come up with an equation that describes the relationship, right? This distance right here. We got to find an equation that gives the distance between this point and this point right here, right? So we know that the origin is 0, 0. And we know what the point here on the graph is.